Solve the system of equations using the addition method. Well, first identify which variable we'd like to try and eliminate from the three equations. And it appears that y might be the easiest one to make go away. Z has different coefficients. X wouldn't have been too bad. But I'm going to use equation 1 and equation 2. And I'd like to label the equation so I can keep track of what I'm doing. And if I simply add these two equations together, we will eliminate y, and then we have negative 5x plus 5z equals 10. Since all of these coefficients are divisible by 5, I'm going to multiply each term in this equation by 1/5. And that way, I have the opposite of x plus c equals 2. And I'm going to call this equation 4. Now I still need to get rid of the y in the third equation. So I'm going to use the first equation again, but this time when I use the first equation, I'm going to multiply it by 2. That'll give me 2x minus 2y plus 4z is equal to 6. And that third equation, I have x plus 2y minus 5z equals negative 4. Adding these two equations together, the y's will go away, leaving me with 3x minus z equals 2. And this is what I'm going to call equation 5. Looking at equation 4 and equation 5, we can see that if we just add these two equations together, we can eliminate z. That gives us 2x equals 4. Solving for x, we can multiply both sides of the equation by 1/2. Now we have x equals 2. The first coordinate of the tripled ordered pair, well, the ordered triple, for the system of equations, x has the value 2. Let's go back to equation 4. And here in equation 4, if we put in the value x is 2, we can solve for z. Negative 2 plus z equals 2. Solving this by adding positive 2 to both sides of the equation, we have z equals 4. Now all we need to do is solve for y. Let's go back to the first equation in our original problem, and that is x minus y plus 2z equals 3. Putting in the values we just found for x and z, and simplifying this expression, we have a minus y plus 8 and 2 is 10 equals 3. Solving for y, we must get rid of the 10. We can add a negative 10 to both sides of the equation. Running out of a little room here. We have y minus y is equal to negative 7. But in order to solve for y, we must get rid of the negative sign. We can do that by multiplying each side of the equation by negative 1, essentially just changing the signs. So the solution to this problem is the ordered triple 2, 7, 4. Remember, we must write our answer in the correct order. Always xy followed by z. Now the only way you'll know that this really is the correct solution is to check it in the original equation. So we need to check it in the equation. Putting in our x value is 2 and the y value is 7 and the z value is 4. We have 2 minus 7 is negative 5 plus 8 is 3. Negative 12 plus 7 is negative 5. Negative 5 plus 12 is 7. 2 plus 14 is 16. Subtract 20 is negative 4. So that's the only way you'll know that your solution actually works, is to check it back in all three equations.